Hello everyone. Today my linear algebraic calculus AAT tech talk topic is filter matrix. Before going into the topic, let me introduce myself. Myself MJ Krishna and I am from Triple Department and my roll number is 2295A0212. So let's move into the topic now. Introduction to the filter matrices. Okay. In this chapter, we are going to introduce the certain notions that are frequent in probability theory and stochastic analysis. Though these filter matrices are frequent in the probability theory and stochastic analysis, which proves the fruitful in describing inverse. M matrices. A matrix concept is mean conditionally exception expectation matrix. A matrix concept is mean conditional exception of matrix. This type of matrix is linear version of partitions and they satisfy the complete maximum principle. So these types of matrices which are going to satisfy the complete maximum of the principal matrices, right? So they are naturally objects in theory of inverse M matrices. Additional, they are also projections and preserve positivity and constant vectors. So we can, for this introduction, we can refer this image for the filter matrices and the image. Right? Move to the next slide. Okay. Let me know that how does filter matrices works. Actually, how does filter matrices work? Let us know that. Filter matrices are used in computations where a new image is created from the source of image. So, like example, as shown in the figure, a new image is created from the source of image. From the source of image, there is a new image is created, and the value goes into the each pixel in the image. In the new image is calculated. It is mainly used for the calculated image by considering what value is corresponding pixel. In that old image is adjustable the computations based on the surrounding pixel, right? This all is going to be so it says about the how matrices filter matrices are going to work. It is image is created by the from the source of the image and calculate the pixels, and these are the matters saying in the first paragraph. And moving to the next paragraph, a matrix filter is just a matrix of numbers, right? Which could be a positive or negative number, whatever it may be. It affect the image of the matrix or filter of the matrix. They usually small and whole numbers, but some filters make use decimals, fractionals, or much large numbers. So second paragraph is going to tell about that a filter matrices is the just of matrix of numbers, which could use whole numbers, small numbers, negative or positive, small fractional, larger. It may be not going to affect the image of the matrix or the filter matrices, right? So we can take example of source image and the filter image. We can see here source image and respectively filter image. To the next slide. Okay, the continuation is the next slide is a continuation of the how those filter matrices work. So the continuation is the center cell is in the illustration is shown with the red border. As you see, is the red border, and to emphasize the is the center of the filter. The numbers in the cell guide how to compute. Computation should be weighed around the surrounding pixels, right? Surrounding pixels. In a calculation that combines value of those surrounding pixels with whatever is the value of the center pixel. So the surrounding pixels is about the what is the value of the center pixel exactly, right? So the particular example is a matrix filter that detects the edge of the raster image. Actually, is that detects the edge of the which is edge of the raster image. Another way to say the matrix is a 3 into 3 as a square matrix. is said to it as a radius of 1. That means the center of filter is surrounded by the cells of in one neighboring layer. So here it is the radius. It means that it is surrounded by the one layer of the one neighboring layer, right? So one radius means one neighboring layer. Two radius means two neighboring layers, right? So this continuation of the how does it work in the filter matrices. So move to the next slide. Okay, example of filter matrix, right? We can see the how matrix filter computations work by doing example manually. Okay, we will use a small 3 into 3 matrix of radius 1 as shown in before, a 3 into 3 matrices of the radius 1 neighboring layer. Okay, a red layer is the center of that, and a small number to make the calculation easy and obvious. In the illustration that follows, we illustrate that the filter matrix is being used on the layer of the left of the illustration. Just for the reference, the matrix used detects the edges, right? The source of image in the illustration represents a portion of the raster image. Okay, as you see in the raster image, which with each cell representing a pixel. The small number in the errors corners of the pixel represents the value of each pixel, right? For simplicity, we assume we are working with a single channel image, right? Single channel image where the numbers are grayscale color or height of the terrain surface. So simple channel images, we here are the gray channel images. Gray channel boxes are there. They are also all uh, sim working on the single channel image, right? Working on move to the working on a simple channel image. Move to the next slide. Yeah. Okay, continuation of an example of the filtration matrices. So the continuation says about that the calculation happens by overlaying the filter matrix into the each pixel in the source of image, doing a calculation of the pixel and the placing the result of the calculation into the corresponding pixels in results image, which results the image, right? To keep this example simple, we will compute only a few pixel in the middle of the image on the both sides of the edge between the region of the lighter pixel and the region of the lower pixel. So these are the examples to keep the example simple, right? Lighter pixel and lower pixel. In the illustration above, we have a overlaid filter matrices into first pixel in the source image we will compute. So the pixel is in the center of the matrices. You can see center of the matrices. Pixel is the center of the matrices, marked in red. Okay, it's marked outline in the red, and the corresponding pixel result in name also marked in red. So which is a center of the pixel is marked red, and the result of the answer will be also marked in red. So here it goes to how does example of a filter matrices, right? So here comes the part of the calculation of filter. How we can calculate the filter matrices? Okay, so let me tell that calculation includes that we move the filter matrices one pixel to the right and repeat the calculation, right? With the numbers it covers. So here it is goes for. So filter matrices calculation 0 into 0 plus 0 of 0 into minus of 1 plus of 0 into 0 plus of 0 into minus of 1 plus 0 into 4 plus 0 into minus of 1 plus 0 into 0 plus 0 into minus of 1 plus 0 into 0, and at least this calculation results in the minus 2, and the result image will be result filter matrix will be minus 2 from the source image. As you can see, result image will be minus 2, which is marked in red, which is source image will be the this two. Source image will be the this two. So from the source image, it filters to the -4 of the red circular box, and at last resulting in the -2. We can see clearly see in the picture. So about this is about the example of the calculating how we can calculate the filter matrices. Move to the next slide. So another way of representation of filter matrices is this type of filter matrices we can represent. We can refer this to the another way of representation of the filter matrix, right? Move to the next slide. Hmm. Types of filter matrices. There are we can see there are four types of filter matrices: average filter matrices, Laplacian filter matrices, low filter matrices, mask filter matrices. So average filter matrices are the same, not like the identity matrices. They all are unique, are the same. One, 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 one. Into three, we are taking example of 3 into 3 matrices. So, so Laplacian matrices is the second type of the matrices, filter matrices. So Laplacians are the 0, 1, 0, 1 minus 4, 1, 0, 1, 4. It is related to the filter matrices, right? Is the type of filter matrices. And 1 by 6th of the part is the matrices is low pass filter matrices. So 1 to 1, 2, 4, 2, 1 to 1 is the third type of the filter matrices. At last, and the fourth type of filter matrices is 1 to 1, 0, 3, 2, 2, 1, 0 is the fourth type of and last type of the filter matrices there in the filtered matrices. Thank you. End up with the section with a warmful thank you for the all for providing the opportunity to present my topic of filter matrices. Thank you. Mm.